Welcome.
So, if Nancy's not here, just want to wait.
Yeah.
Stragglers.
That's
Wanna say,
a,
where's Hank?
snack break.
Yeah.
You are dead. Yeah, of course. Watch it, I'm having your back. Watch your back.
Can you send me a link? I don't think I got it.
To this?
My draft. You can do it after the after the
Okay.
session.
Yeah. There's Nancy.
So that's why I didn't know. I didn't receive it.
Do you want to do the honors, or do you want me to do it?
Oh.
So, thank Nancy. We're ready to start.
All right. So it is time. I'd like to start promptly so you can get to the social event on time and early. This is the second session for remote attestation procedures. And we are in the last session of the meetings. The first thing we would like to do is to convey our enormous gratitude to Nancy, who has served as chair since the inception of the RATS working group. So if we could all give a round of applause and thank Nancy for all of her hard work in keeping this organized and helping get the working group going. Thank you. All right. Do you want to take over? And
Sure.
you do a good job.
All right. So let's get started. Just a reminder of the note well. This outlines your rules for participating. So please, I'm sure you've seen this a zillion times, but please be aware of it.
Be aware of it, and it's your responsibility to read the various documents referenced and make good decisions and understand your what your participation means in mailing lists and in the sessions.
A reminder of the code of conduct. Please be respectful of others and make your comments impersonal. Also, make sure that your comments are aimed at the global internet as the target for making things better, and encourage your participation. Thanks for those who volunteered to take notes. And let's dive into the agenda. So we have, this is our agenda. There are a few last minute changes. Was our question?
Yes, you're speaking.
Can't hear. Okay. All right. So here's our agenda. We have had a last minute change. We're going to flip around Michael Richardson's topic. But that was conditional that Michael Richardson was here. Is Michael Richardson here? At 16:05. Okay, so we will then move to the next in line, which would be the PKIX evidence talk.
Okay, can I move your backpack?
Sure. Sorry about that.
Okay, hello. Update on this thing that's moving. So this is, yeah, how do we want to frame this? Next. I can go next? I can go next. I cannot go next.
Is it letting you go?
You're missing a piece. Here's a USB-C if you flip the other end. Okay. We found it in the parking lot. It's okay.
You sure?
Okay, so this piece of work is somewhat related, but also somewhat unrelated to the LAMP CSR stuff. So this is sort of out of this PKIX evidence design team, as a reminder, is largely a group of HSM vendors like PKXS 11 device manufacturers who want a way to attest properties of either the HSM device or of a specific key stored within the HSM device. We want to do it in ASN1 because we're all ASN1 shops and we're aware that CBOR is the future, but we're not the future, so fine. Um, so this is evidence that may end up inside a CSR in the LAMP CSR test, or it may end up somewhere else. It may be a thing you can ask for over P11. That would be really cool. Or it may be a thing that who knows? Who knows? So this is sort of related to a CSR, but not exclusively related to CSR. It sort of is an independent thing. So we've sort of ended up through navigating this design space. We're sort of doing an ASN1 DARE port of EAT. And I'll get to this as an open question at the end about whether that's actually what we've been asked to do in full or whether we're allowed to take a shortcut. But yeah, so we're sort of trying to do all the EAT things in a DARE wrapper and then also add some more claims that talk about things an HSM might want to tell you about itself. Like, is it in FIPS mode and what is the key purpose and is this key non-exportable and all that sort of stuff. So we're making progress somewhat, not quickly. The first sort of roadblock. So there's we're still doing crypto design. We're trying to figure exactly what the wrapper format looks like. It obviously needs to be some sort of claim set. Probably it needs to be. Sorry, I'll talk. So we agree as designers that we need a claim set. We probably need a format that allows us to put in arbitrary claims, and all of them are optional, and it needs a signature on the outside. We have not yet defined exactly what that looks like. I think we're not ready to bring that question to RATS. It's really almost more of a PKIX question than a RATS question. Exactly what this signed out data should it be? Should it be CMS as a profile of CMS, or is that carrying way too much baggage? Should we define something new that sort of looks like CMS, or should we define something new in ASN1 that actually looks more like CWT, like a CBOR signed token? Like, I think we have to figure that out, and we're not ready to present it. I'm not sure that RATS is the right group anyway for that. So I'll skip that, but we do have a couple questions, design questions, to present to the RATS group that I think we do have the right expertise in this room to help resolve. Next, please. Okay, so the first thing that has come up as a problem is we're basically taking EAT, like the entirety of the EAT draft, and taking all the CDDL in EAT, and we're rewriting all that CDDL in ASN1 to just like take all the EAT claims with their exact semantics and just smack them over into the ASN1 DARE encoding. And then we ran into submods, and submods is a beast. It tries to do all four of these things, and then once we add also a DARE encoding, we're now going to have 9 combinations of like DARE in DARE and CWT in DARE and DARE in CWT and JWT in DARE. And it's like, so like, what do we do with transcoding submods into ASN1? Lawrence is in queue. Lawrence.
Let Lawrence answer on behalf of that.
And use the tool. Lawrence.
Yeah. Okay, can you see me? So,
and by the way, maybe, you know what, actually, let me do my next slide because the authors believe we have an answer. Maybe let me do the next slide. And if you're going to answer the question in this slide, maybe I will attempt to answer the question on the slide first. Okay. Tomas gave us an answer, which is use CMW. All problems are solved with one layer of indirection, add a CMW. Okay, back to you, Lawrence.
Yeah, that I don't subscribe to that solution. Because the complexities inside of CMW are, I mean, I'm trying to get my head around the sort of combination of EAT submods plus CMWs and its recursion, and that's you thought EAT submods were bad. You put those two together, and like now you're like it's like squared or cubed, right? I don't have an answer directly. I mean, I mostly want to acknowledge that EAT submods are complicated. And I think the answer is probably content types, a very simple structure with content types. And I thought we were actually close to that. All you really need to do is have a content type for the submod. But anyway, I want to keep engaging on this. And I mostly just wanted to acknowledge that the complexity is there and also comment about the compounding complexity with CMW.
So Lawrence, you've been great on list. Like the authors of this draft are really trying to do a thing which isn't this, and we've sort of, I think, been gatekept. Yeah. We have to do this before this is accepted. So like, this is crap that we don't want to do. So if you can help us do it, that would be great.
Yeah. I'll try. My fingers in too many pies, but yeah.
Hank.
Yeah, hi, this is Sang. So I wouldn't know how to do this in ASN1 either. Like literally, I have no idea how the nesting would be distinguishable, how to deal with the signatures that come with evidence, and then you would have to nest that. And so yeah, so maybe you don't have the C versus J problem. That's I think something you don't inherit. I think when you go natively with ASN1, I guess.
Octet string versus AI5 string. Printable
Okay, and
ASCII
then you have
versus
that. Okay,
octet.
see, you have similar problems. Just coming back to and just breaking a lance for the CMW. Simple example, media type for TPM quote, media type for canonical event log, put them both into the same message, throw it to the peer. So CMW is not intended to clean up the mess that is the EAT nesting, I think.
Next. Gary.
Curie?
In addition to what Lawrence said, I'm still not convinced that in practice you will have mixing of mixing of token types like you had mentioned, JOT and CWT, CWT and JOT. Would that have simplified the problem if you didn't have to look at every single combination of that's possible with the submod?
I mean, I can speak from my design team. The HSM people don't care about C or J. We're going to be DARE all the way. So we need to nest ASN1 things inside ASN1 things. Don't care about the other combinations. So it's, yeah. Right. Okay. Great. Next thing. Hannes has
Sorry.
imported this. What, was there more in the queue? I'm sorry.
Curie,
Yeah.
I can queue if you wanted to.
I'm sorry, Lawrence. I'm sorry, Lawrence. Yeah, go ahead.
Yeah, just real quick. I mean, the important point for all of this nesting is that compound is the composite compound attestation is when you're testing something like an airplane or a car or something like that, you don't get to pick the formats of all the different components you're combining. So you really do have to be open to all of them. I don't think it's as bad as it's like coming across here, but that compounding is. I think that's important, and to be able to handle that. And even though if it doesn't, not important for your case, Mike, I think it is important to really try to at least give a shot at that, because you know, and also in DIR and your point, the DIR format stuff is so prevalent in security that it's going to show up in an airplane or a car.
So not as chair. The question I have for the group really is, do we have use cases that support all of the different, possibilities for nesting things and wrapping things? Are we taking on too much as a work group?
I think I just gave you a use case.
There's sort of the theoretical use case, and then there's the the real world use case of who is actually going to use it. And so I think Mike's comment was, hey, we don't see anybody asking us to do this way.
And I just to tack on to Ned on that, if you have too many things and they're not getting used, I think that's confusing for developers.
Yeah, so I think that question comes too late for EAT. That's there now. So, and I guess some additional claims might describe how the nesting works. Just don't inherit the problem. You need hierarchical stacked evidence parts. Just create a nesting and dependency claim-ish thing that is in there that is not an EAT. That is to be kind of describing why or what the relationship between the nesting is. Maybe even that is not necessary because it's always profile specific. If it's an English text, I don't know, but don't inherit as just said, without a need, don't import a profile requirement for using that evidence format. I think that's wise.
Okay, this is the smallest, tiniest part of this draft. Like we're trying to do a thing which is nothing to do with submods, and like this is now like the pile of leaves that the rats live in next to the bike shed. Hannes, you're in the queue.
Yeah, I'm wondering. I think Lawrence has a point here because it's a little bit tricky to predict already, like what all the different combinations would be. But it's easy to see that some of them are likely to occur, specifically composite devices, and which we're already seeing today. Like they produce stuff in all different shapes and forms, and so, like for example, you have a composite device, you have a microcontroller in there, produces something in an EAT, you need to wrap it in this ASM1 structure as part of an HSM. Like very likely.
I have
that
3 minutes
something that
left
can-
and more slides.
Okay.
We got the queue.
That's Lawrence. And you're not in the queue.
Lawrence, and then we close the queue.
Yeah, I don't think it's as complicated as everybody's thinking it is. I think basically a content type and a binary blob is all you need. I mean, the EAT kind of looks funny because I didn't do that, but I don't think we're that far off.
Okay, yeah, thank you for the input. I feel
We're
like
gonna have
watching all
to
my minutes
take it
tick
to the
down in
list.
yellow font.
Yeah.
Hannes, did you want to say anything particular about this other than that you did some hacking work and it looks pretty? Excellent. Next slide. So this is another point that we need debate on is like, what's the gatekeeping that RAT's working group is actually asking us to do before this can move on? Like we believe we have been asked, although the number of voices doing the asking is us n equals small number. So I'm not sure if the working group has asked us or like specifically Lawrence has asked us, but I think we've been asked to split this document into two. I think we have been asked to do one document, which is porting EAT into DARE, like just take EAT in its entirety and just take all the CDDL and make ASN1 equivalents and call that a full document. I'm going to say this into the microphone and then regret every shred of my life. Step one here can be maybe properly called a DARE web token, DWT. And then step two is we have a bunch of platform attestation and key attestation claims that are specific for HSMs. We're basically just going to take all the CK underscore properties from P11 and lift them up into a claim set. And it's been pointed out that some of these might actually be useful to backport into regular EAT, C EAT and J EAT. So that becomes now a second document, is this whole new claim set, and we'll define all of those in all three encodings, or CDDL and ASN1. Is this what the working group is requiring us to do? There's a lot of work here, which is like not critical path for our use case, but is like not a ton of extra work, modulo submods being a mess. So can I get confirmation that this is the mandatory work that we have to do to get our P11 thing through? Is that a fair question?
Do you want to do show of hands? Okay.
Okay, it's Liang Xia from Huawei. I don't have the answer for you, but I have some question to you. Firstly, simple question. What is the relationship between this draft, this PKIX evidence, with another draft in LAMPS, the CSR attestation? I want to know what is their relationship.
Common question, unrelated. CSR attest defines a slot in the CSR where you can put anything, put bytes. This draft is defining a specific set of claims. You may put this into a CSR attest. You may put a JSON encoded EAT into a CSR attest. You may put this into something that isn't like.
Okay, so
that is an envelope. This is a potential payload.
Yes, yes. So they can work together, right? Okay. It's about one is about the container, one is about the content, right?
Correct. Yeah,
okay.
That is a very good.
Okay.
Yes.
And the second question is, I think it's not so simple, but I want to know because I see your last page, you mentioned the key attestation. So in my understanding, the key attestation is all about the key, how the key is stored, how the key is endorsed or hardware protected, right? But we see a lot of times about the attestation, about the plan for attestation, the client attestation, server attestation. So firstly, I want to confirm, right now you are doing the key attestation for this draft, right? So do you have the very clear definition of these different kinds of attestation and what kind of thing you are doing and what is the future in the industry community want to do? Actually, this I think is maybe a future correct question. Okay.
That sounds nice as a question. I'm not sure the answer is so clear. There's a weird fuzzy, certainly with like a smart card. You know, this is a physical
No,
chip in a
I'm doing it
physical
anyway.
device that holds one key. Where's the
Let's see
boundary
that.
between the devices in FIPS mode versus the key is in FIPS? I'm not sure the answer can be separated.
Yeah,
so
yeah,
cleanly.
I understood.
Okay,
Okay.
I'm going to ask that you write down your questions and we get back to this later because we have a few people that have very limited time slots. So we have
Okay.
to stay on our schedule
Okay.
to accommodate people in the NOMCOM who are probably exhausted.
So let's take a look at the poll. Looks like we had 3 people say yes, 1 person said no, and 4 people have no opinions,
Resounding.
and a lot of people not participating.
I agree. So we may have to take this to the mailing list as well, and we can discuss during the open mic session. We have plenty of time later. Thank you.
Can I get off the stage yet?
Yeah, we
Yeah,
have to
you're
switch.
done.
Thank you.
Let's go.
All right, next up, we're going to go to Remke Krishnan on Trusted Confidential Computing Mesh. So we had an agenda bash. Mesh.
Mesh. We can't hear you. Yeah, all that work. You want to do Sandra? Yeah, we're not getting your audio. I don't think so.
No, unfortunately. Is someone there that can help us? We can't hear our remote speaker.
He needs to rejoin the meeting.
Can you rejoin the meeting, please? That way we can hear you, Rumke.
Maybe he can't hear us.
All right, he's doing it. Hey, Ned, you're on this. Do you want to start or no?
Okay, while he's rejoining the queue, I will get started and hand it off when he gets back. So basically, this is we're highlighting a use case called Secure Access Service Edge as a use case for attestation. Ramki, we can hear you.
Okay, perfect. And then why don't you finish this slide? Let me continue, please. Yeah.
Okay. And so RAT's architecture anticipates, that the verifier role can be divided across multiple nodes. And this use case highlights doing that. There's some issues or concerns that we want to discuss having to do with the consistency of trust in a distributed environment. So consider, verifier inputs that need to be grouped together in some meaningful way. Then the timing of the verifier inputs and outputs need to be coordinated across sort of multiple nodes and domains. And then in the context of, say, securely connecting nodes, do they agree on the trust state that each peer is in? So all of those have something to do with the consistency of trust in a distributed environment. So I'm going to hand it back to Ramki to talk more about the SaaS use case.
Thank you, Ned. So basically, Secure Access Service Edge essentially is applied to any traffic from any enterprise user for accessing applications in the cloud or internet or essentially SaaS applications in the cloud, right? That's what you see in this picture, right? And imagine now in any enterprise, you can have thousands of work from home employees or affiliates, right? Who are using these cloud applications, correct? And SAS is essentially a zero trust exchange doing some critical functions such as, secure web gateway, etc. Right, firewall as a service, and all those. Right, but fundamentally, what are the SASE challenges? There's a possible attack surface increase due to diverse infrastructure, diverse geographic locations with different regulations, and most importantly, these SASE functions terminate the TLS connection. That means you are processing material in the clear, for example, passwords, right, or tokens. Next slide, please. So going further, just expanding on a specific SASE instance with all the functions, firewall, IDPS, cloud access security, broker, etc. While SASE does a good job of essentially isolating different tenants, right, today, the bigger challenges are exploitation of vulnerabilities in OS, for example, Linux, to get root access and then get hold of memory content. So basically, any admin who has root access to the OS, right, can get hold of the memory contents. It could be an admin or an attacker with admin permission. And typically, often malicious an insider, right, who has access to the compute systems with higher privileges and scrape the memory, right, and retrieve secrets, retrieve all sensitive information. Next slide, please. So basically, how to address the problem, memory scraping problem, you can bring in SASE into the under confidential computing, protect it using confidential computing. So any root access, exploiting vulnerabilities, malicious administrator, you cannot see the container's memory. Basically, the process memory is completely hidden, right? You cannot scrape it, you cannot do anything. That's the benefit of using confidential computing for SASE. Next slide, please. So with this, now we see that SASE can benefit from confidential computing. Then how will a CC confidential computing attestation solution work for SASE? Here we have taken a background check example, right? Essentially, you can see in this slide that, hey, basically the client is a relaying party, basically the enterprise work from home employee affiliate, right? Connecting to the SASE entity. And what is the process, right? So essentially, if you look at the steps, the first one is there is a centralized verification service. That's the typical usage model, which periodically opens a connection, maybe once a day or a few days. It opens a TLS connection to the reference value provider and fetches new reference values. Step number 2, the client opens new TLS connection to SASE. And 3, and get the SASE CC workload evidence, right? And number 4, client opens new TLS connection. This is 4 to centralized verifier, supply SASE confidential compute workload evidence and get the attestation token. Number 5 is client verifies the attestation token and opens new TLS connection to add to SASE, right? And this is before accessing all the enterprise applications that behind SASE. So what is really the challenge here? The challenge is really the centralized verification. When there are thousands of affiliates, work from home employees who are simultaneously using the verification service, this could be a bottleneck, right? Next slide, please. So what's our suggested approach? Essentially, idea is to distribute the verification function to the client for scalability, right? So what's happening here in this picture, the client is not just a relaying party as in the previous picture, but also got a verifier, right? Correct. Basically, in this case, since there is a verifier, the step number 1, the client verifier periodically opens a new TLS connection to the reference value provider and fetches new reference values. It could be once a day or a few days. It all depends on the policies. But please note this is an infrequent operation. Next is after that, the steps will be very similar to the one for the external verifier. So basically, client opens new TLS connection to SASE. Then step number 3 is getting that SASE CC workload evidence. Then instead of the remote verifier, the client connects to the local verifier. The client is basically the relying party and the verifier. Supply the SASE CC workload evidence and get the attestation token. Last is the client verifies the attestation token and opens a new TLS connection to SASE before accessing the backend applications. So what is the benefit here? The verification is distributed to thousands of clients, addressing the centralized verifier scalability bottleneck. One important thing to remember is the client verifier needs to sync with the RVPs only periodically. That's a fundamental assumption. Maybe once a day or once in a few days. Next slide, please.
So you have someone in the queue. Do you want to take questions now or wait to the end?
We can take now. We have some time, right? Yeah.
Sama to you, Tristan. So if you go back one slide, please. On the last slide, you had the flow where you were mentioning that now the step 2, 3, and 5. Can you explain why you need these 3 TLS connections? It's the same relying party and the same attester, right? So why do you need these 3 different steps? Maybe I missed something. Why is it required?
Problem is each one, the 2 and 3 is one TLS connection.
Okay.
Right, as a single TLS. So
Yeah.
we are assuming that, hey, you create a short-lived TLS connection, right? Basically get the evidence, right? So
Yeah.
and then you close the connection, right? After 2, 3, then you connect to the centralized verification service, right? Step number 4, and then reopen a TLS connection number 5. So essentially the assumption in making this is a short-lived connection to SASE, the step number 2, right? Because we don't know whether the verification will fail or not. So fail or succeed.
Okay, so basically, if I understood it correctly, so you are saying that you basically in 2 and 3, you are collecting the evidence. In
Correct.
that connection, you close that connection. And
Yes.
then after verification, you reopen a new connection, which has nothing to do with the connection that you had in 2 and 3. Is it correct?
That is correct.
So
Yes.
how much time? So I'm a bit worried about, so how much time would be in between 2, 3, and let's combine 2 and 3, and between 2, 3, and 5. How much time do you expect in your use case it will be, or the kind of use cases that you are thinking about? How much time will be there?
So this is exactly why. So one of the things about centralized verification, right? Like when you're talking about thousands of endpoints, we don't know how long it will take for the centralized verifier to respond.
Can
Step
you
number
give me
4.
like roughly like some order, like is it milliseconds, seconds, days, hours, or rough scale? I'm
So
just trying to understand.
maybe let's assume like the interesting problem with the centralized verifier is that it depends on how much capacity is provisioned, right? Correct. And then suppose there is a peak demand, right, on the client side, right? Like everybody's like kind of in the morning, everybody starts up and then tries to attest to SASE, right? You may have a burst there, and then you'll hit a long tail with respect to centralized verification, and it'll take maybe sometimes even minutes, right? Retries and land up in a minute, right? So that's the fundamental problem. We don't know how long it will take. It can have a long tail, right? Correct. Long tail effect with a centralized verifier. Typically, centralized verifiers you won't over provision, because once you beyond the burst, you would often see some sort of not everybody trying to connect at the same time, maybe just hundreds connecting at a time, right?
Okay. All right. I will give others the opportunity. I have concerns here which are related to security, but I will talk again. Thanks.
But this is just the background check. Yeah. Model.
Gary Mundy of MediaTek. So, yeah, thanks for this presentation. One thing that I'm wondering why you didn't address is the client itself could be confidential compute compliant, and you could be dealing with the lift and shift scenario where the employee is processing a workload and he just realizes his local machine is just not going to do the job. Yet there is no flow here for your client, for the client to attest before the workload is moved into a SASE container. So I'm wondering if the scalability challenges that you're talking about actually won't fully disappear if you take into account the client attestation before the workload is initiated. So is that something that you're considering, or do you feel it's not necessary in this kind of architecture?
So at least so far, what we are saying is, yes, we will also talk about like what are the implications for the verifier itself. At least we feel it should be confidential computing. But to your point, if independently the client could be running in confidential computing, completely agree. But then just consider the number of client endpoints will be much, much larger than the number of SASE endpoints. Like here, the scalabilities could be thousands, even, like consider a big organization, it could be even 50,000, 100,000 employees, right? Correct. Whereas the number of SASE endpoints is probably much lesser. That's why we didn't present that problem as like benefiting largely from the distributed verification approach.
So you have 3 minutes, by the way.
Yeah. So let's move ahead. Yeah. Sorry, we'll take questions in the end. Yeah. Okay. Great. So basically, what are the key architectural aspects to address? So basically, running client verifier and confidential compute. This is because today centralized verifier run in CC, right? And the verifier security promise doesn't go off due to the distribution. And the second one is provisioning thousands of client CC verifiers in a scalable way. So number one is orchestrate verify plus the relying party policy. And also verifier community may not be homogeneous. It's a very critical point, right? So basically, the client could belong to an enterprise and the SaaS service could be offered by completely a different enterprise. Or the SASE, in this case specifically, could be from a totally different enterprise. For example, Zscaler is an enterprise by itself, a SASE provider. Third point, address eventual RVP consistency model in thousands of client CC verifiers. What would it mean? The RVPs need to continuously update the reference values and timing of verifier inputs to ensure consistent attestation results needs to be taken care of. Last but not least, secure channel should be bound to SASE host and client platforms via attestation, right? Something to think about, SASE TLS endpoint load balancers don't tolerate long session establishment latency. Freshness of SASE adherence is determined by SASE update management. Last slide. So RAT's recommendations. So basically, these are some options to consider. Essentially, orchestrate verify plus relying party policy. So basically, it's not clear if we could kind of use that draft IETF RATs, right? MPS groups to bundling of RV endorsement objects is one possibility. And it could be possible that the WIMC domain group ID works for nodes that are not in the domain that manages the MPS bundling. This is one stream. And then the timing of verifier inputs to ensure consistent attestation results. So basically, some draft to think about the draft IETF RATs epoch markers. Bell can be coordinated across multiple independent reference value providers, and also what constitutes consistency of trust, right? When things are constantly changing, that also needs to be worked out. And last but not least, TLS endpoint binding. How the attestation result is bound to TLS endpoints. These are the recommendations we have.
So you have people in the queue?
Yogesh Deshpande, my question to you is that instead of multiplying the number of verifiers to address the scalability problem, you are just trying to kind of do the same thing by accompanying it with the relying party. Have you considered that other alternative of having multiple verifiers in that situation and then routing it intelligently to based on the load?
So the fundamental problem is when it comes to cloud computing, right? You want to be you want to be using resources on demand, right? And that's sort of where I think, yes, the problem is like basically how do you the difference between the min and the max, right? Correct. And also you have to remember that when it comes to cloud computing, unless you pre-reserve resources, there is no guarantee that the verifier resource will be available when you ask for it, right? The min and max is very, you need to be very careful in how you provision the cloud, right? If you provision your min very low and ask for a max, the max way exceeded the min, you may never land up getting the verification resource. So those are the cloud computing considerations. But if you provision close to max, then you're basically back to the problem where we've pre-dedicated a lot of resources. Whereas what you're really saying is, hey, there is kind, right? And this is like a simple function which can be sort of brought in there, right?
Yeah.
Right. That's the idea.
Maybe we discuss offline. There's a few ideas I can share. Yeah. Thank you.
Yeah.
Thanks up.
Yeah, this is Henk, and then just in the interest of time, I'm just highlighting that some of this problem space seems to be an overlap with the multi-verifier ID that Huda created.
And posture assessment.
And posture, yeah. So yeah, maybe this is this discussion how to what problem goes where to specific. That's all. Yeah.
Yep. Yeah, I think there's going to need to be a lot more discussion on architecture and before a go forward.
So Sama again, basically, I think such kind of discussions when we talk about a tested TLS, we should be very careful about specifying whether we are talking about pre, intra, or post. Each of them have their own properties, and I found that to be completely missing. And I posted some questions on the chat, which I didn't find answers to also on the mailing list, and also your presentation didn't cover these points. So I would repeat, what are the mutable components that change at the runtime? Number one, what is the expected duration of the connection for TLS, and what is the expected maximum lifetime for the TEE? And to add to that, I didn't found it to be clear how you are maintaining the freshness of your design. If you go back to slide, I think it was 7 or 6. So can you elaborate on that?
Slide 7 or
6 or 7, any one of those. So
This-
how
this-
is the
yeah.
freshness with respect? So you got an evidence in 2 and 3, and you assume that until 5, that evidence still remains applicable. Is this correct? And where is the nonce coming from? Is it coming from the verifier, or is it in the previous slide, in the 6, you had them separately, relying party and the verifier separately. So now the nonce is coming from the verifier or from the relying party? Who is generating that nonce?
The basically the verifier is the one. So both are possible, actually. Both options are possible, correct?
Okay.
Because in this case, both are valid options for the background check model, right? Because SASE is the one which is attested, right?
But what's your proposal? That both are valid, I know from REDS, but what's your proposal?
So my approach would be to get the nonce from the verifier. That's probably the most secure, right? And the same thing
but then this is wrong, because if you need a nonce from the verifier, then 2 and 3, you are already doing the evidence, and then you get a nonce in step 4. What do you do with the nonce?
So that's why these are options, right? Like basically, so the whole idea is one approach would be, if you're doing peer verification, then you're saying, hey, I'm verifying my peer, then you don't need to contact the verifier to get the nonce, right? Correct. Basically peer verification. Then it goes back to the relying party itself can supply the nonce, and that's this model described here, right? So that's the assumption here. Because
So you have
I'm
two
verifying
nonces.
my peer.
I'm gonna jump in here. Can we take this to the list? We need to move on to the next
Sure.
item, but we'll take one more question if it's quick.
So just a recap of the multi-verifier draft. So our key concept is that the ruling party will generate the nonce, and all the verifier will use the same nonce. And then you always maintain the same TLS connection between the ruling party, and multiple verifiers and the related party and attester. So, and further discussion, we can discuss it in the chat and by email. Thank you.
Thank you. Okay, next up is Michael. What? Me? Yep. Ooh, cool.
This is the most efficient nom-com ever. I am super hyper, so I may babble. Thank you for accommodating me. So I've got a lot of emails about various things like, why isn't there a RATS protocol? Like, how do we do RATS? Like, why isn't it like, I don't know, Radius or something like that? Okay. And why is 9334 not defined a protocol and blah, blah, blah. Many of these are unicast questions and sometimes questions at other non-IETF events for people that barely can read an RFC. What I would like your help with, and I think that I would like to maintain a wiki page. Next slide, please. Maybe this works. I don't know. Right? Yeah. Oh, you didn't plug it in. Yeah, so you've probably all seen this XKCD at some point. That's the short answer, right? That we came here to try to unify other things, and we needed to do that effectively from the inside out. So we have good specs on evidence. We have some growing specs on attestation results. And we have some growing things in the as I understand it, because I was seeing some of the slides remotely, this last conversation that just happened, like, whoa, when do we get the nonce? And that kind of detail of the protocol is really important, but we also need to just keep track of where that's actually happening. So next slide, please. And that's like the only slide. What I want to do is I want to collect the set of protocols that may or may not carry evidence, attestation results. I don't care how it does it. There could be 27 different ways of doing it. But what I care about is being able to redirect people to where this goes. So I see Mike over there, and he's done a really good job with CSR attestation, for instance. Okay, that is an example. Yeah, okay, we didn't get him to do it in, he couldn't do on version 1. Yeah, I just put an EAT here because that wasn't compatible with his target market, right? Better to get the people in the tent pissing out than outside the tent pissing in, right? Okay, it's one of those actual things where people think big tent kind of things. I hope that didn't violate the code of conduct, but
yeah, just make sure if someone is listening on audio with their child, they can listen.
Well, yeah, okay. But I think that it's appropriate to explain to kids that
Well, let's move on.
Where you go, right? Point is that he needed the people to come to him and join him and participate and help. And to do that, he had to meet them halfway. And that's just fine, okay? Wasn't our preferred magic, XKCD converged thing, but that's okay. So what I want your help with, and it says we have 12 minutes. So I actually hope you come to the microphone and tell me which pieces are missing. And I don't think there's another slide. Oh, maybe there is. Yeah, there is two more slides. Come and tell me what's missing, right? So when I went to go through what's carrying attestation results, I came up a little bit blanker than for evidence. And so that's what I want to do. As I said, I will put this into a wiki. You can unicast me, you can put it on the list. You can say in application area blah, I don't know what we would do. And that's okay, we can put a question mark in there for that. Hank.
Yeah, I'm going to say that in the current review phase, and Thomas is pushing me into a sane level here. Chara can be used for, the interaction model ID is talking about all of these kind of timing problems where you said where goes the nonce where.
Right.
So that is but it is a guideline. That's not a protocol.
That's right. It's not a protocol. And exactly. so when the people show up
we go with the remote attestation attester API ID. where we want to have, that's embryonic. The idea is there, sets are there, where we have testing environments and an agent, that could be a lead attester or a tester manager, and maybe we do the symmetric thing for the verifier side. So with the verifier set and an API set and maybe a agent there that is either the master verifier, the distributor, whatsoever. Maybe there's some symmetry there, so there's
Yes.
incubating work. We would love to get your feedback on that, but this is not this IETF, maybe the next.
So what you described sounds fantastic, but go back to the XKCD slide. That was the 15th protocol. Oh, okay, fine, but sort of not. I actually want the list of what are the 14 protocols that, you know, in an ideal world, we would have unified into the 15, right? You can't get the buy-in from those other people or that for the unified protocol if you haven't gone and considered their needs. And for their needs to be considered, they at least need to be on the list, right? And also, I want to be able to go, like many of us go to other places. I don't know. I once went to the Automotive Ethernet Congress. Scares me because may never get into a modern car again. But that's actually the reasoning why, is I'm like, well, okay, you talked all about security, and then I asked them some fundamental questions about certificates and remote attestation, and yeah, we like that. How are you going to do it? Yeah, we like attestation. I'm like, but how are you going to do it? And they didn't know, right? So they were really big on security and MACsec and other stuff like that, but it was useless because they didn't have a layer on top of that to establish the trust process, right? And so many of us do go to those places, and being able to point to say, well, these are some things that do them. Are you using one of them? Oh yeah, we're using TLS. Okay, and with certificates? Oh no, we just use PSK. You know? Oh, I'm sorry. Excuse me. Please go ahead. I was sort of hoping the chairs would please.
8.5 minutes left.
Yeah, please.
So, Yogesh from so you have made a good question. I think we should help support document because you have kind of missed some important evidence protocols, and I just noticed you missed some important attestation result protocols as well.
Of course.
Yeah. Thank you.
I totally expected that, and Cunningham's law, right?
Hey, Dave Thaler.
Dave Thaler. Who's next?
Just a question on the scope of your question, Michael.
Yep.
Are you want to, because I understand you're doing a wiki, do you want to collect things outside the IETF as well?
Of course.
Okay.
Yes,
that answers my
everything.
question.
Yep, I want all of the things, and I mean, even if they're unreadable without 6 NDAs, but you can put the title in, that's okay. At least we would know there's something there we should think about.
Yeah, I'll just repeat my conjecture that you know well, that every authentication scenario is an attestation scenario. And
Yep.
so I expect it to be unbounded, which is kind of what you said when you start off. So thanks.
Yep. I'm going to work through the people in the queue, in the remote queue. Okay, unless you're already there, then go ahead. Yep.
Yeah. Okay. So again, I think the point, I have 2 points. One is that remote attestation as an architecture, but if you think underlying that, there is basically also a protocol. So when you are saying that we want to use it, so when you say that this is basically only an architecture, not at a protocol, I think it's completely wrong, because you have an attestation nonce which is completely different from our protocol nonce.
Sure.
I will give you an example of TLS attestation, which the draft you have already written. And by the way, on the next slide, you have not written this. We also support in the attestation results, the same draft also applies there.
Yep.
Anyway, the point is that the attestation nonce is different from that protocol nonce which the server and the client have.
Yes.
So I would consider that by any definition of a protocol, that this is a protocol in itself. It's getting a nonce. It's generating.
I don't want to. I don't care to litigate that point. I totally accept it. Yeah.
Okay.
Yeah. I don't. It's not important to me that
Yeah. Okay.
to make
And
any
if you-
distinction. I want to have the list at a high level,
Mhm.
at a manager's pointy-haired boss kind of level of, these are some things that are happening. The detail that you just discussed is important,
Mhm.
but I'm not interested in I'm not going to I'm not going to exclude anyone from the list based upon
fair
what
enough.
happens. Yeah.
So I have, in one of my presentations, I will point you to that. So we had outside of the IETF also some protocols like SPDM include by default within that some measurements and attestation. So I will point you to that. That might be helpful.
That would
for
be
you.
fantastic. Thank you.
Sorry. As a point of order, like asking from to fill out this slide as a mic queue was like a horrible idea. This would be better in an email, so we should do that. Having
Sure.
said that, you helped me present at Acme, WebAuthn, and then also Acme.
So right. So I mean, I'm good. You know, I did say it in email, but also I am invoking Cunningham's law. If you know what that is, right? Best way to get an answer on the internet is to post the wrong one, right?
Monty Weisman, Beyond Identity. I'm also somewhat speaking. We have a TCG Trust Computing Group and TPM.
Right.
Since you're asking for volunteers and outside of IETF, I will offer my assistance. And
Thank you.
TCG has defined a number of firmware and Linux-based IMA formats that fall in this category, and I will be happy to contribute.
So you said formats, and I think that goes to what Mohammed said, which is that a little bit like one of the things that we need to understand is if there's a freshness nonce in this protocol, how does it happen? Now that's a detailed technical discussion, right?
You could do that too,
But
yes.
the point is that ultimately we have to have that conversation, and here's a list of things. And when someone comes along and says, well, how do I do this? We can, well, you can look at what TCG did in a document, blah, 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 blah. And that's what I want to be able to say.
Yeah.
Okay?
Right, and that's in scope for my offer.
Right. Thank you. Who's next?
You have 4 minutes.
4 minutes.
3 people in the queue. We
Yeah.
locked it. If you want, we can unlock it.
Okay.
Who's next? Is it me?
Jerry?
Yeah.
Yep.
One thing I'd like you to distinguish in the context of 93334 is not everything needs to be a protocol, even though there's an interface associated with it.
Sure.
So, you know, because I know, you know, and there are other people in the room who can even talk to that. There is work started on APIs and, you know, for instance, in the context of endorsements and provisioning and reference values, that is an API, right? And I mean, anybody can figure out how to build a management interface that works over the web that works
Right.
with that API.
Yeah.
So I assume you'll eventually want to add to the wiki with the list of APIs that correspond to the.
I maybe where I write protocol, write thing.
Oh,
Okay. Okay. Just evidence. What are those other evidence carrying things, right? As Mike has, he has a CSR. It's not exactly a protocol. I mean, it is ASN1 encoded, blah, blah, blah. But one of the problems is we don't have a round trip. We only often get once, you know, sent to us. And then the question is that really work in the world? But anything that could carry evidence, let's talk about it.
Okay, 2 minutes.
Okay, two remarks. So sometimes the evidence and the attestation results are used different protocols.
Of course.
Okay.
Yeah.
This is the first remark. The second remark, maybe we can add the protocols to deliver the nonce or time of freshness. For example, in the CSRs, actually it's 2 protocol.
Right.
Actually, you can use other methods to deliver the nonce.
Yep.
Okay.
And if there's 2 choices, let's write them down and let's see what they are. Yeah. Someone else? Peter?
Yeah, it's Peter. So like the 2 works I'm currently working on mostly use rats and heavily. So one was the Acme rats thing that discussing with Thomas and Monty and Mike. So it's about CMWs for getting a certificate before getting a certificate. Another one is so the other one is using it in Azure. So it might be if not transmitting evidence over TPM Trara, they might be transmitting over other telemetry protocols that might need some extensions. Just 2 pointers.
Thanks. Anybody else? Queue is locked. 1 minute. There we go. Thank you very much.
Thank you, Michael. All right, Dave Thaler is up next.
All right, let me know if my audio isn't working fine. I'll just go. Talking about RATS endorsements 03. Next slide. All right, so back on September 24th, Ned posted a email about working group last call, allowing 2 weeks. Is there any more discussion on these drafts regarding working group last call? It's a bit ambiguous as to whether this was actually starting a working group last call or asking for comments before starting a working group last call, but that's neither here nor there until we get to the next steps. Did get comments from both Carl and Kathleen. And Carl said, I reviewed in support of working group last call. In general, the draft is fine. It could probably progress as is, but I did want to talk about the feedback received. So next slide. And by the way, we have not posted an update since that time, but the GitHub copy has new things, and that's what I'm going to be presenting here to see, do we make any other edits before we merge and post? And so all of the comments do have things that I posted to the list. So Carl had 3 points. The first one overlaps with Kathleen's, and so I'm going to cover both of theirs before giving you the solution or the proposed change. So Carl said, may benefit from more discussion on how trust is established in endorsements. Now the binding from endorsements to target environments is established. Okay, he mentions there's no mention of either in the security consideration section. Actually, you are presenting the old slides, not the one that were just approved. So this one won't have the updated text. I can still discuss it verbally, but what's on the slide is not what's in the latest pull request.
I approved it.
We can try to look for it.
You're welcome to. Otherwise, I'll just cover stuff verbally.
Okay, you can do it verbally.
So initially, I tried to say, here's a piece of text that says there's some text that's in section 4 on endorsing verification keys that was intended to talk about the binding part of Carl's comment. But he's right that there was nothing in the security consideration section, which overlaps with Kathleen's part. And so first I tried putting some text in section 4. My co-author pointed out that that's not where Carl suggested it in the security consideration section. And so that paragraph or an equivalent to it is actually moved into a different section. So what's on the slide there is not what's being proposed, although the text there is almost identical. It's just as follows, points back to section 4. So if you can go forward to the first slide that talks about Kathleen. In this deck, it's probably about 3 forward. Keep going. I'll come back to these because I want to cover them together. One more. Okay, here we go. So Kathleen said, I'm also wondering if there are additional security considerations on the layers, differing sources for policies mentioned in the draft, and formats for developers or implementers. Okay. So if we looked at the draft before, you can see on the left, there's no top-level security consideration section. Okay. Well, you can argue that that kind of violates what the RFC rules should be. There was a security consideration section, 6.1, which was underneath endorsement format considerations. And so it did talk about security considerations around formats for developers or implementers, but there wasn't an explicit section that talked about the other points that Kathleen mentioned. Okay. And so what we've done in the GitHub version is that there's now a security consideration section now inserted right before ANA considerations. And the other ones are labeled for formats. Okay, go forward 1. And so this is the other part of security considerations, plus the paragraph that was shown on the slide that I had for Carl. So this one, the intent is that this paragraph plus the other paragraph together, the belief of at least Thomas and I is that this helps to sufficiently address the comments, given that there aren't new considerations that were brought up by the reviewer. It's important to explain the relationship and terminology. And so on this one, we refer to 9334 around the security considerations around the attestation of layers, right, which are highly relevant to Kathleen's point, but I didn't say that in this document, even though there's a layered attestation diagram. Sources of appraisal policies, and then this refers back to section 4. That's the one that I pointed to that Carl had commented in my response to Carl. And section 4 around 6.1 around considerations around formats. Okay. Now, if you can go back to the slide that you had up before, just so people can see that one paragraph there before going on. The main point Carl talked about is referencing some abstract state that must be present in the verifier. That abstract state is in the paragraph here. It talks about storing one or more trust anchors in its trust anchor store. That's a type of abstract state. The verifier's trust in an endorser is expressed via storing that in the endorser, and the binding is done as follows. And in my updated slide deck that you can find in the proceedings, it has the actual text that you can see in context that talks about what that is. And so my belief is that was there, it just wasn't described as binding. And so the intent of the security consideration section, as it says that the binding, just to use the term Carl was looking for, is actually what's discussed in this section where, again, on the updated version of the slides, and I've highlighted the specific text that I'm talking about. So I really appreciate Carl's review, and I would invite Carl to review the corrected text and see if that sufficiently addresses his comment. But Carl had two other comments here that I also wanted to cover before I open it up for questions. So next slide. All right, so Carl also correctly commented that there's the discussion around timeliness of an endorsements may be worthwhile as well. There is discussion of actual state relative to points in time, but not how endorsements fit into timeline. Okay, and so we added, at least in the GitHub version, there's a pull request there that has this text ready to merge or edit and merge, and it says timeliness. Since specific protocol documents are also responsible for documenting how timeliness of the endorsement itself, e.g., using a certificate lifetime, is provided. Right. Shortly before this section, it talked about things that specific protocol documents were responsible for doing around endorsement. So that's the also here. This adds one to that list. It points to the 8.1 around timeliness of claims and evidence. 93.334 actually has a section called timeliness. It talks about that, and it sort of refers to that around the claims in the evidence. And so when additional static claims are provided in endorsements, no additional steps are needed for the timeliness of those claims, since they're static rather than dynamically varying by time. Once timeliness of evidence is verified, any matching conditionally endorsed values can be applied. So that's about the timeliness of the claims, but not about the endorsement conceptual message itself. If endorsements ever carry dynamic values in the future, e.g., whether any vulnerabilities in the version of firmware are currently known, then the same timeliness considerations as for claims and evidence would apply and would be the responsibility of specific protocol documents. And it refers to 2 points in 9334, which this updates for further discussion. Okay. I will happily take Gary's question right now because everything else is a nit after this. And so go ahead.
Do you believe that the appraisal policy itself will carry information on the timeliness of endorsements?
The appraisal policy itself, as discussed in the document, talks about how to appraise actual claims, right? This document does talk about how actual claims come into evidence and endorsements. And so that's the long version of saying yes to your question.
Okay, so the link would be that the appraisal policy can talk about when endorsements get stale to trigger the verifier to get fresh endorsements in order to actually validate evidence. Would you say that? Yeah. Okay. Thanks.
Okay. All right. So I know we're over time. Everything else is just yes. I deleted a word for the nit, and so the last question is for the chairs. Is next step? You can go to the very last slide. Yeah, I deleted a word. Okay. Last slide is just next steps is since it was a little bit ambiguous in Ned's question as to whether working group last call was started or not, what do the chairs want to do next? Do you want to run a 2-week, verification? But I am ready to submit the document, the next update, like as soon as you say go. It could be during this meeting. So
yes, I think all outstanding comments have been addressed. It would be good to kick off a working group last call. Ned, do you disagree? You agree? So let's do it.
Okay, so unless Carl stands up and says, no, wait, I had a comment and you didn't resolve my stuff, then I'm going to go ahead and post that today. And then you can start the working group last call when you want. So.
Thank you. And so we have one more. I made a mistake and we skipped over security considerations of attested TLS. So that's Mohammed. Apologize for my error. And we're going to be tight on time here so that we have 5 minutes reserved for open mic with some of that reserved.
15 minutes.
So how much time I have?
15 minutes, but exact.
Okay, can you reset time? All right, last presentation of IETF. Thanks very much for this opportunity to talk to you. And Yeah, there are a lot of misconceptions that I would like to just clarify via this presentation. Of course, I do not write internet drafts, but I find that the drafts becomes RFC, but they still remain problematic. Like the security considerations of RFC 9334, I'm quite unsatisfied with that. But anyway, let's talk about it. So the next slide, please. And thanks to Confidential Computing Consortium for providing me the funding to be here. Basically, on the left side, you see remote attestation. I agree that's a remote attestation architecture, but as I said in Mike's talk, so basically there is a protocol underlying that. And unless you think of a protocol, this being combined with some other protocol, which is carrying some other information and protecting that traffic, you can't really combine it with anything else, right? So if you always try to think about it as an architecture, so you are designing something which will never be used in the real life. Unless that's a protocol, you will never have that architecture applied anywhere. So that's the fundamental misconception that is there. So there is a protocol, even if there is an architecture, there is a protocol underlying that from any definition of a protocol, which is on the left, that it is getting a attestation nonce and not a protocol nonce. We need to distinguish between these two, and then generating some claims. Either they are pre-generated like boot time measurements, or they are generated in the runtime. So getting these claims from somewhere, from stored securely in some memory or whatever that place is in the registers or whatever that getting mechanism is. So it gets these claims, signs these claims along with the nonce that it has obtained, again the attestation nonce, and then conveys it over that channel back to the verifying relying party. And I have a very simplistic model where I have combined verifier and the relying party just for the purposes of simplistic view. And finally, at the verifying relying party, the appraisal is going to happen. So this is the complete protocol from any sense of the protocol in any interpretation of that protocol. So I would not call it an architecture. Of course, if you want to see it as an architecture, that's fine. But there is, of course, an underlying protocol which is shown here. Anyway, on the right is the most commonly used protocol of the world, which is the TLS protocol. And then in order to combine it, so in order to combine these two protocols, what we do is basically we have to compose these two protocols. How do we do it securely? So that's one of the questions that we address in attested TLS. Next slide, please. One way to do it is to do it trivially. Everything that the TLS does, just repeat it all over again, and then use that attestation nonce and submit over that channel and do that. But a more efficient way will be to combine it in one of these three forms, which is pre-handshake attestation, post-handshake attestation, and intra-handshake attestation. And each of them have different properties, as I was mentioning in the Ramki's presentation. Next, please. So how we visualize it is basically like this, that there are different channel bindings involved. On the right, on the extreme left, you see that the time is going downwards. Either you can do, so there are now two protocols that we have seen, the remote attestation and the TLS handshake protocol. So one part of the TLS protocol. And the important thing is that which is happening first in terms of time going down. So I can have remote attestation first and then the TLS handshake protocol. Or in the middle, you see the post handshake solution, which is doing the TLS handshake first, completing that and using the exporter to be used inside the remote attestation. And finally, you have the composition of these two protocols interleaved together, which is saying that the TLS handshake uses an exporter, and that's imported into the remote attestation protocol. And then the remote attestation protocol is sending over the evidence into the TLS handshake, and which is the strongest possible kind of binding that I can have, such that the two are bound together. Next, please. So here is an interpretation of how we can see visually all of these three at a very high level from the TLS protocol. Pre-handshake attestation, and I take the view of client as an attester. Of course, this also applies to server as an attester, but just as an example, just to see, client as an attester will of course generate the evidence, and pre-handshake, it will happen before the TLS has started, right on the top left, and then it will be conveyed as part of the certificate message of TLS handshake. And finally, the appraisal happens when it has received that as part of that certificate message at the server end as the verifying relying party. A secure channel is then established. Next, please. Intra-handshake. So what happens here is that instead of generating a pre-generated attestation evidence, it is generated within the handshake. As I said, it's using some of the parameters from the TLS, using these exporters inside this to have one-way binding. And then it's again put inside the certificate to create that second kind of binding. And then it's sent over as part of certificate message again, appraisal happens, and then a secure channel is established. Next, please. Still, the client as a tester to have a comparison of all these. Post handshake, TLS connection is completed. It's the secure channel is established. And then after that, the generation of the evidence happens. Now there is a round trip which is required. You send over a attestation nonce versus the nonce that was up there for the TLS, client nonce, server nonce. And then it's conveyed over that secure channel using the secure channel that was established using TLS, and then appraised at the verifying relying party, which is the server here. Next, please. So in order to combine all of these protocols into one form, just to visualize them, what is happening. So we have here the client as the attester on the top left, server as the verifying relying party, and the green is showing basically which things I can export into the remote attestation part. So firstly, you see EKM, which is representing early exporter keying material. And then the TLS also provides you the EKM, which is after the step 2.4, which is the exporting key material. And then in evidence, in case of pre and intra, that is evidence is a part of the certificate message 2.5. And at the very end, you have the post handshake, which only applies to post handshake, which is that we have a nonce coming from the verifying relying party and going back to the sending back the evidence generated afterwards using some of the exporters from step 2.5. Next, please. Okay, so all of this is good. So what do we write in the security considerations, which I find to be incomplete, sorry. There are some base security properties which are to be provided by some of these protocols. And next slide, please. TLS has well-defined properties. They have been formally verified, formally analyzed, and all of the work has been done in around of 2018 and so on. So there is an appendix inside RFC 8446. Next, please. However, the problem is that now when I want to combine this with the remote attestation, it has no defined properties. What do we want to achieve basically from all of the remote attestation architecture? Next, please. One of the properties that we came up with was per session evidence freshness. And again, as I said, so this has to be distinguished from the protocol freshness, which is provided by TLS in this case, attested TLS. And that is representing that how recent is how recent are the measurements which are in the claims of these this evidence. Next, please. And secondly, the integrity of the evidence. If the evidence, and for first one also, and all of these properties which I'm mentioning, I will argue that whatever protocol of the world you use, you actually need these properties. There may be some use case for which you may argue, yes, we don't need, let's say some specific property. For instance, that my claim XYZ is only the set of fuses which I installed at the manufacturing of the device, and it remains the same forever for the whole life. And I would argue just put it as part of the endorsement, and you don't need to have attested TLS for that. Why do you need attestation at all? So the next one, like integrity evidence, that is also one of the properties that one would always require. You don't want that evidence to be modified, these claims to be modified on the way of the transmission up to that other party, the verifier or the relying party. Next, please. Okay, so the third fundamental property, relay attacks, which is never mentioned in RFC 9334. That's the very fundamental property. If I can use someone else's evidence, I get a nonce, attestation nonce, and I forward it to someone else. I get that evidence and I present it as an evidence from my side to somebody else. That's completely ruining the process of that whole remote attestation. So I would stop here. Mike, go ahead.
Mike Ellsworth, we had a quick chat before
Yeah,
the
he means replay.
replay or replay?
So it's not replay.
Replay. He described replay.
I didn't describe replay. So there is a distinction between replay and relay. Relay is basically that I got an attestation nonce. I forwarded it to someone else. I got his evidence and I showed it. So for example, let's say you sent me a nonce to prove my status. I forwarded it to Hannes. I said, hey, send me your status. I just pretended to you that this is my status. Replay will be that we had an earlier conversation and I replayed that evidence back to you. So there is no third party. Relay has a third party for which I get an evidence and show it to be my own evidence.
Okay.
Okay, Mike Hounsworth. We chatted a bit earlier, but for the record here, I think some of the security assumptions that you're challenging here get you into like weird circular relations. Like if you're expecting each claim to be independently fresh and each claim to be independently integrity protected, then that means you don't trust the attesting environment. That means you don't trust the measurement collecting environment, and that like has weird implications for the whole thing. So I'm not sure I totally follow you with where you're
So
going.
firstly, I'm claiming that if that evidence was, these claims were actually modified, then that's no use of attestation at all. I'm not saying what happens inside the attesting environment. I'm saying that this property must hold. How it happens is the implementation detail, that how it is implemented. But these are the fundamental requirements that one should actually specify, and they should be part of the security considerations. Yes, please.
John from Huawei. So several remarks. So for the first one, the persistent evidence freshness, I think it depends because it's necessary persistent because you have a period to do the attestation, you have a period of the TRS, so that it does not necessary you need to attestation for every session. So I think that this is not part of the work in the.
For some use cases, yes, but for strong security, I would argue this will be required. This will be good to have.
But it's not necessarily specified in the RFC.
I'm not, that's what I'm complaining about, that RFC is not describing these. That's what all I'm complaining about, that security considerations of RFC 9334 should have mentioned some things about this, and it does not. That's what I'm claiming, that RFC 9334 should have a base which should actually address these concerns. That's what all my talk is about.
Okay, and for the replay attacks, actually,
Replay or relay?
Already, you're talking relay. Okay, okay.
So one idea is write this up, put it to the list. An option might be to add it as errata to save up. Well, then it gets tagged with the document as opposed to opening it back up right away. Okay, yeah, that's a good idea. And updates.
Okay. Yeah, lots of slides.
So another point is that in your, can you go back to one slide or one slide when you have the interaction figures?
Okay. The pre, intra, or post.
So when you have the one time array for the nonce, and I think that it depends on which kind of protocol. I say that. So what kind of protocols for?
So for which property are you talking about? Is it the evidence freshness or?
Yes. So for the evidence for the nonce generation, it depends on what protocol you use to deliver the nonce. So in some cases, you need to request for the nonce.
I would disagree. I would disagree. The reason is that that is the server nonce and the client nonce, which is the TLS nonces. And this is, I'm talking about the attestation nonce, which will be used to,
Yes, I'm talking about attestation nonce. So
then that I would argue has nothing to do with the protocol. Whether you take it ad hoc, whether you take TLS, attestation nonce has nothing to do with the protocol. TLS protocol, RFC 8446 never talks about attestation nonce because that's completely, they never predicted that there will be something which will be attestation, which will be added to the TLS protocol. It's an extension to the TLS protocol. The base TLS protocol or any protocol of the world can never talk about attestation nonce because they never expected that this would even be a case.
Okay, next question, please. We have about 1 minute left.
Okay.
Next, please.
Next question from me or from?
No.
Thomas.
Thomas, just to give you a bit of context, because when we did the architecture, I raised this, and there was I raised an issue, and in the discussion we agreed that this was not an architectural problem; this was an interaction problem, and so I moved that to the reference interaction model draft. And then it stayed there. I don't know. I don't remember how and if we addressed it. But in the meantime, we did the PSA, right?
Yeah.
And in the PSA, in the security consideration, we have exactly the text that addresses this problem. So it's a protocol thing. It's not an
interaction
architectural
model
thing.
only says that scrambling of the nonce can actually lower down some of the relay attacks. It never says what these special attacks are, what these type of relay attacks are. But I would still disagree with you. I would say if you say an architecture would be used somewhere realistically in the world, that has to define that these are the security considerations that you should consider, independent of whether that interaction model is or that should be a part of the security consideration of that specific draft.
Okay, we can discuss this because we have 6 seconds.
Yeah.
So, but
Thank you. Hank, You have about 30 seconds.
Or less.
Well, I'm being generous.
So yes, when you use a nonce, you have certain problems and certain attack vectors. If you don't, you have different. They depend on the interaction model. That's why this all goes to the interaction model IID, which we currently really are reviewing. So if you want to put a relay, replay, or other, I want to say, nonce differentiation concerns into that context, I think the interaction model ID is the best place to do it. Again, the architecture defines the roles and the conceptual message flows. More to your protocol-esque diagrams, these are in the interaction model ID. So maybe helping us get your concerns addressed there would improve that document significantly. Maybe we can try that.
Yeah, as long as there is still a reference in the RFC 9334 that there is some interaction model. Yeah,
you can update. You can't update the
I would then suggest
just
updating
a new reference. That is.
I would then suggest referencing, because in the confidential computing consortium, people, I already mentioned in the SAG, so people use it as a holy book, RFC
Okay.
9334.
All right, thank you. So
Thank
as
you.
a next step, could you please write a draft that would be intended to be an updates to 9334, and it can begin discussion on the list. So not adopted yet, we'll just go from a draft as a first step. And Gary asked for 2 minutes, and then we have Deb for 2 minutes, and we're done.
Right, thanks.
First thing, the CCA EAT profile that myself, Thomas, Simon presented at the last IETF, we're proposing that for working group adoption. So please carry on next steps with the editors and on the mailing list as appropriate. Second thing, carrying on this conversation, I'd like to propose and I can take the lead on this, writing a helper doc, purely informational, on attestation evidence, all the way from an application layer, following up a little bit on some of the issues that Asama pointed out. It would be non-normative. That would be what would be used to complement 9334. I don't think an extension of 9334 is appropriate. So if the chairs say yes, I'll go ahead and write the document, whoever, and maybe I'll work with Asama and others offline. We'll get that in place before the next, before 122.
Great, we go from drafts to figure out what we adopt. So that would be fantastic. Thank you. Deb.
Oh my goodness. You told people whatever. So I'm here to talk about like status of what we have in the IESGQ. So EAT is fine and moving along, and it's not a problem, right? It's actually being in the same cluster with something else that's waiting for it. So once it gets issued, that other draft will also move along, right? So that cluster is not a red flag. I am UCCS, we're holding until you clear the discusses. I'm also holding media types hostage once again, fun times, because I want them all to make sense. I want them to make sense. So you need to, if you have media types in UCCS, you need to be sending an email to the media type DEs, whatever the media type process is, and get things moving along the way they're supposed to. We will forever get discusses about media types if you don't follow the media type process, which is what you've got from both Ori and Francesca on each of those drafts. Pardon? Yes, because they're sure that I'm going to hold it until you get it squared away, because I've promised. So squared away. Once you get it squared away, we'll push it. UCCS is Roman's, media types is mine. I can only hostage media types. Okay, so that's just your warning. So my other comment to this working group is, if you propose briefing slides a half an hour before the meeting starts, your chairs are going to struggle. You need to post your briefings earlier than that. It's unrealistic to expect to post a package at 3 o'clock for him to have ready to go at 3:30. So that's just a note to being nice to your volunteer chairs. Thank you.
Thank you.
All right, so that is it. We're at the end of time. Thank you all for your hard work. We'll see you on the mailing lists and hope you had a good week. Safe travels. And thanks again to Nancy. Can you send that Git link?
Oh, yeah.
I'm sending a message out, so
I posted a pull request to the wiki because they won't let me edit the list of groups. So Greg will have to merge it, but they might ask you whether my RATS wiki entry is, they may ask you whether my proposal for